Hello, students. Welcome to the subject of cryptography and network security. We are into module 3 now. In module 3, we are going to learn about the hashing. The first session on hash function, what hash function is. Right, let's begin. So, hash function, suppose consider that h is a hash function. It takes the input data m of variable length and it produces a fixed size hash value, right? So it means that there is a function which is h is a function. We call this as what? Hash function, right? Hash function. As you can see in this diagram, you have a message which is m, and it is of arbitrary length. Arbitrary length means variable length. Arbitrary is nothing but variable length. There is no size for it, fixed size. So that the message is taken as the input, and output is nothing but your hash value. Okay, this output is fixed value, fixed length. If suppose consider that hash function is designed for security, then we call it as what? Cryptographic hash function. So basically, why we can make use of hash function? Hash function mainly ensures what? Integrity. So when I talk about integrity, you know that it helps us detecting whether any changes being made to the current message or not, right? So the message, say consider there's a communication happening from source A to destination B, and say that over the channel the message hi is been sent. Now whether any alteration is done to this or not, whether it is altered or not, that is what is integrity, right? Suppose along with hashing, say consider I applied encryption also, right? Along with hashing, I apply encryption also. In such cases, we can provide authentication as well as confidentiality. That is, authentication is verifying the sender, whereas confidentiality is protecting the content, right? So by encrypting along with hashing, or encryption along with hashing, can also provide authentication and confidentiality. Okay, now let's try to find the properties of hash function. First property is about compression. So what compression is? So it's compression. Meaning of compression is nothing but how much, whatever the size of the input messages, the output is always smaller than the input size, right? Say consider, suppose consider the message is, say, hi, hello, how are you, right? So this is my message. This is taken as it is and fed into the hash function. Okay, hash function. Now output, it will be of, say consider some 5 bits, or say 6 bits. Right? So this would be constant for different messages. You give hi as only the input. You give hello as only the input. You give how are you as only the input. You are going to get only this output, this 5 6 bits output. So that is what is compression. And then pre-image resistance. So what does that mean? What do you mean by pre-image resistance? Is if I have the input message m, if I have the hash value h, it is very difficult for us to find the original input message, which means it is more like a one-way function, right? One-way function. We call it as trapdoor functions. One-way functions. When I say one-way function, you can convert, you can obtain only h. From h, it is difficult to obtain m. What is h? Hash value. So, and m is what? Message. Weak collision resistance, strong collision resistance. What is this property? These two property. Weak collision resistance says that if there is message 1, Okay, it produces, say, consider hash m1, and say there is it is difficult for us to find m2 such that h of m2 it is equal to h of m1. So what it says is we have one message m1 and its hash value. The weak collision resistance says that it will be difficult to find another message which would give the same hash value. Now, what is strong collision resistance? Strong collision resistance says that it will be hard to find any two different message such that their hash values are equal. Right? So strong resistance and weak resistance, there is a slight difference, that's all. Right, their first message is given and its hash value is given. Now I'm trying to find the second message whose hash value is same as first one. It is difficult, that is weak collision. You're trying to find two different messages having same hash value, that is your strong collision, because these are the properties of hash function. Coming to the characteristics, what are the characteristics of hash function? A good hash function should be fast to compute for any given input and must also accept data of variable length. First thing is it should be fast and should accept variable length input. Variable length input should be taken as the input, right? Suppose if there is a small change in the input message, then it should lead to a completely different hash value. Say I send the message hi, hello, and say consider I got the output or the hash value as say 53h67. Okay, now if I change this message to hi, hello, then the hash would be 412e3. Look at this, and look at this also. What is the change? The change is one L is missing, that's all. Only one bit is missing, but you can see that entire hash value is changed. Right, so that is another characteristics. So it must satisfy one way property, meaning that it should be difficult to obtain the original message that we just seen. Right, so it is another characteristics. The next characteristic is the function should make use of all the input data. So whatever input is there, complete length of input should be taken by the function, and it should produce hash value of fixed length. So even similar messages must generate very different hash values. This ensures that stronger security and uniqueness. So the hash value of same message should also be different. Right, means once I give that message, I get an hash value. Another time I give a message, I should get a different hash value. This randomness, if it is there, it gives more security. That is what it says. So this is about the hash function, its properties and characteristics. Thank you, students.